Hello everyone, welcome to Pepcoding. So in this video, we are going to start the next question of our tree series, and the question that we have this time is add one row to tree. Okay, so it is an interesting question, really interesting question. So let us have a look into the question, that what we have to do into this. So in this question, what will be given to us is a root of a binary tree. Okay, so think that a binary tree will be given to you. Okay, binary tree will be given to you, and after that a value and a depth. These two will be integer. Okay, so this kind of input will be given to you, and what you have to do is the question statement is saying that if I tell you the statement is go to depth d. Simply I'm telling you, simply go to depth d that is given. Okay, d is a depth that is given, so go to depth d and add nodes with values val. Okay, val is the value given to you, so go to depth d and add values val. Okay, so what is the meaning of this? See, let me make a binary tree first. Okay, so that we can understand what is the question statement. So here is a binary tree: 1 2 3, okay, 4 5, not looking like 5, and it is 6. Okay, suppose it is a binary tree. Actually it is a binary tree. Okay, so what we have to do is, see, let me tell you what is depth first of all. Okay, because something depth is given, so you have to understand what is depth. So depth, it is saying that as it is in level 1, right? So it is saying that this is depth 1, this is depth 2, this is depth 3. Okay, and if there is some node at this, then this will be at depth 4. Okay, so this is how it defined the depth. Depth means the level at which it is, at which the node is. Okay, it is at first level, so it is depth 1, second level depth 2, third level depth 3. Okay, so this is what the depth is. Okay, so I hope that depth is clear. And what it is saying, the question statement is saying that at depth d, okay, at a depth d, add nodes, I mean add row of nodes with value val. Okay, what it is mean, it means suppose it is saying you are given depth is equals to 2 and value is equals to 7. Okay, so at depth 2 you have to add 7. So how it will be added, let me show you. Okay, let me show you how it will be added and how the output will look like. Okay, because when I will show you the output, then you will feel much comfortable about your thinking that how to do it. Okay, so now the output that we can get is, see, 1. Okay, at depth 2 it is at depth 2, right? It is at depth 1, it is at depth 2. So my depth 2 will become a new depth with value 7, right? This will now become the depth 3. Okay, because we have to make depth 2 as 7 with 7 values. So this will become 7, this will become 7. So at depth 2 I have added this 7 and 7, and the rest of the tree will remain the same. Okay, will remain the same and will added in the same corresponding way. That is 2 was in the left of this, right? So in the left of this 2 will be added, and 4 5 was like this, so 4 5 will remain as same. Okay, and 3 was in the right of this, right? In the right of 1 we have 3, so we'll add 3 in the right of this, right? So now 6 will remain as same. Okay, so this will be the output of this tree when depth will be 2 and value will be 7. So I will keep it aside. Okay, I will keep it aside because we have as the test cases are not present right now for this question also. Okay, so what we are going to do, we are going to match our answer. Okay, so we will keep this as our reference, and now after that we'll match our answer. Okay, this will be the first test case, depth 2 and value 7. Okay, now let us say depth is 3 and value will be suppose 9. At 3 you have to add 9. So how we will do it? So now let us keep it this side. Okay, we'll keep it this side and let us try to make the answer. So the answer that we can get as it will be at depth 3 we have to do this 9, right? So we'll say 1 1. Okay, and then after that we'll have, it is at depth 2, so don't do anything with them. But at depth 3 add 9. Okay, at depth 3 add 9. So here we'll get 9, here we'll get 9, here we'll have 9, here we'll have 9. Okay, and then after that in the left of it it has 4, in the right of it it has 5, here it has null, so it will remain null, it has 6, so it will become 6. Okay, and we will keep it aside. Okay, so this is what we get for this test case. Okay, for this test case. So okay, one more edge case that is I think most important. That is, suppose someone is saying at depth 1 add 9 or add 10 or add some value. Okay, at 1 means at root you have to now add into the root. That means your tree, your root will be changed, see, till now the root is 1, but when we are saying at depth 1 add something, so call let us call 5. Okay, add a node with value 5. So then at that condition you should make a node with 5 and add rest of the tree into the left of it. Okay, it is a edge case. 4, 5, 6. Okay, rest of the tree will remain same, but at one depth what you should do, you should add this one. Okay, what you should do, you should make a new node. Okay, and add the rest of the tree or the root node to the left of it. Okay, this is what it is saying for depth is equals to 1. Okay, so we will also keep it as a test case. Okay, we'll also keep it as a test case. We'll test into this also. So these are the 3 test cases. And now approach. What could be the approach? So think about it. What could be the approach? And then after that I will tell you that how we can solve it. Okay, so if you are thinking in a correct way, or if you are thinking let's say in the way that you previously have studied. Okay, so what you have studied previously, think again. Think, if you have to add something at depth 3, we can say. Okay, this is depth 1, 2 and 3. Suppose here you at this point you need to add something. Okay, depth 3 means at this point. Okay, this will become the depth 3, so at this point you need to add something. That means after 2. So if you will have these nodes, these 2 and 3, so can you add something into the left of it, something into the right of it, and can add the previous left to the left of it, and the previous right to the right of this one, and the previous right to the right of this one? Can you do this? Yes, of course you can. How you can? See, now your main task is how to get this thing, how to guess this 2, 3, and if you need to add at this point, suppose at this point, after this if you need to add something, then what you need these 3, right? You need these 3. So how you can get this? It is quite simple. Can you see that it is something that is increasing in a radial way? What is it? Isn't it breadth first traversal? Right, we are increasing in the breadth first way, right? You need something that is in the breadth of a tree. So what you do to get some element of the breadth of the tree? I will say we travel in a BFS, that is breadth first traversal. We traverse through BFS. So when we traverse through BFS, we get the required value of a corresponding, or the required, we can say, or the required breadth, right? This is the first breadth, or this is the second breadth, this is third, we can say third level. So it is level order traversal, right? Level order traversal. So this is what we can do. What we will do, see, suppose if I want to add something in my depth 3, right? So I'll get the values of depth 2 and add something into the left of it, into the right of it, and before that I will save its previous left, I'll save its previous right, and I'll save for this one also, and then I will add my required values node. right? Required values node to this one, to these two. Okay, so this is the simplest answer that we can give, right? This is the simplest answer that we can give, and this is the only answer. This is also the answer that you can code. Okay, this is the answer that you can code, not the only answer, but this is the answer that you can code. It is quite simple, right? It is quite simple. What you have to do, simply do the breadth first traversal, save these nodes that are one above to the required depth, to the required depth. Okay, so how you can stop here at this point? See, when you traverse to the complete tree, then at that point you stop at 1, right? You stop at 1 when my size is equals to 1, you stop at that point. So when you need to stop at this, so what you will do, you will simply stop at depth minus minus when it is greater than 2, right? Because we need to stop at this depth, we need to stop at this depth only, because we need to add at depth 3, so we need to stop at depth 2. When we need to add something into depth 3, we need to stop at depth 2. So how you can stop at depth 2? That is when you will stop at 1 will remain. Okay, when 1 will remain. Okay, so that means depth minus minus is greater than 2. So I hope that this point is clear. Okay, this point is clear. Okay, one more thing, the constraints. The constraint will be the depth which will be given, the depth which will be given can be more than the depth of this tree also. Suppose the depth of this tree is 3, right? So depth can also be given as 50. So in this case also you have to manage something, that is you have to return the same thing, that is the same tree, that you cannot do any change in it, so you have to return the same tree in this case. Okay, so I hope all the points are covered, and and also the approaches is covered, right? So what is the approach? Approach is, we'll traverse in a depth first way, I mean the breadth first way. Okay, we'll traverse in the level order. Simply I'll say we will traverse in the level order. We'll save this level elements, okay, and we'll add its something, and we'll add the required node to the left and right of it. Okay, and before that I'll save these previous nodes. Okay, and after that, after adding the node into this, I'll add this node again to the left of it, right? Node, it is, suppose it is node. Okay, so first of all I'll save something, that I'll save this. I'm saying this as the node, right? This as the node. So I'll save left is equals to node dot left. Okay, now I saved this. Okay, and right is equals to node dot right, and then I will add this node dot right. I'll make node dot right is equals to new node, right? New tree node with value val. I'll add this into the left of it and into the right of it, and node dot right also, node dot left also. Suppose it is left and it is right. Okay, so I'll add into both left and right my new nodes, and after that I'll add left of left again left, I mean this left of left again will be this L, and right of right again will be this R. Okay, so this is quite simple. Okay, this is quite simple that we are going to do. Okay, so I hope that I have covered all the points that are required, so we can easily code it. So let us try to write the code for the same. Okay, now let us go to code it. Okay, so let us now look into the code of it. Okay, so in code, what we were doing, we were simply doing a level order traversal, and we're saving the element one depth before that of the depth in which I want to add my new row, right? So I'll traverse using q, right? So I'll make q of tree node, right? Why tree node? Because I need to access left and right pointers of this, so that I can add something to left and right of it. So that is why I'm making q of tree node, right? Q of tree node, I'll say this pq. Okay, I'll say this pq, and I'll make one more q, sorry, I'll make one more q, so that I can get the particular level element in one queue, and after that I'll prepare the second queue for the next level. Okay, so I'll say this cq, child queue. Okay, this is my parent queue and child queue, and I'll handle the condition when I have to add into the root depth, right, in the first depth. So when depth is equals to 1, see, in this condition my root will be changed, right? So I need to return the another root. Here I can return this root only because I in other condition I will add something in between the roots, in between in I mean after the root. Okay, I'll add something that will come after the root in the tree. Okay, but here I need to change my root only, so I should make a new tree node and I'll call it node is equals to new tree node, and with the value val. Okay, with this value I'll make a tree node and I'll make it root. So how I'll make it root, I'll say node dot left is equals to root. Okay, now root is in the left of it. Okay, root is in the left of this node, so that means this node is my root. So now I'll return this node. Okay, so return node and node dot left is equals to root. So now I'll simply do the level order and we'll try to get the elements of the required level. Okay, so simply for that while, but before while I need to add one tree node to my queue, right? So pq dot push, what I should push, root. Okay, now I'll do while my depth minus minus is greater than 2, right? Is greater than 2, so that I can reach to one depth before that of the depth in which I want to add a row. Okay, so I'll do depth minus minus is greater than 2, and one more thing, I'll write pq dot size is greater than 0. Okay, why I'll write this? Because see, suppose if depth will be greater than the actual tree depth, right? Suppose the depth is 50 and the tree depth is only 7. So should I traverse till 50? Like, should I traverse 49 times? Because at 49 I think it will be null of null. It will be a null pointer only, right? So that means I should traverse only while my tree is completely traversed, right? While my up to the number of nodes in my tree. Okay, not more than that. You can also do one more thing. You can calculate the depth of the tree and you can make a check that if this depth is greater than the tree depth, then you can return the root only, that you cannot add anything to it, so you can return root only. But I am not making one more function for that, so I'll simply do, okay, traverse at most till the last node. Okay, so this is what I'll do, and after that what I should do, I need to do work for particular levels, right? So I need size, so pq dot size, and after that what I will do here, simply while size minus minus is greater than 0, right? And first of all tree node rem is equals to pq dot front. Okay, and then pq dot pop, then prepare the next level. That means when rem dot it is tree node, right? So when rem dot left, when rem left is not equals to null, then you should do something. That something will be cq dot push, we should push rem dot left, right? So this will be pushed, and same for the right, same for the rem dot right. Now my rem dot right is not equals to null, then add this, right? So after coming to this line, at this line my next level will be prepared. Okay, and my work for the previous level will be done, right? So what I should do here, I should simply make a new queue, not just make a new queue, just will point the queue. That means tree node star I should do temp, that it will be equal to, it will be pointing to pq, right? So it will be pointing to pq, and after that my pq will point to cq, and my pq will point to 10. Okay, so this is what I'll do. So with the help of it, my elements of my child queue will be transferred to my parent queue. Okay, and then parent queue will do the work for next level, and it will do work till my depth minus minus is greater than 2. Okay, or second condition is while my pq dot size is greater than 0. Okay, it will do work till then. So after that what I have did, I stored all the elements of my particular level that I want, right? Suppose I want to add some elements. I want to add a row at depth 5, right? At depth 5 I want to add a row, and for that I need elements of depth 4. So with the help of this loop, with the help of this these two while loops, I have recovered element of depth 4, right? So now I have element of depth 4, or either my pq will be empty if the depth is greater than actual tree depth, right? So these two are the conditions when this will break, right? So here what I will do, I'll simply check while, not just check, I'll just run a loop while pq dot size is greater than 0. Okay, and my pq will only enter into this loop when I have my elements of a particular depth of which I want, right? So otherwise I can simply return root, right? I can simply return root, because if my pq will not hit this condition, then that means the depth that is given is more than that of the actual tree depth, right? So after that I'll hit this condition. But when I will hit this condition, so what I should do, I should simply add a new row, right? Add a new row to the elements that are in pq, right? I should add a new row. So for that what I should do, I should simply make a tree node, not just make a tree node, I'll simply remove first of all first element, right? Tree node star, I'll say this node again. Okay, tree node star node is equals to pq dot front, and after that pq dot pop. Okay, so this is what I will do, and after this I have my element, after which I need to add a new row, right? So what I should do, first of all I should store somewhere that what is my previous left and previous right. So I will say this tree node pl. Okay, previous left is equals to node left, right? And tree node star previous right is equals to node right. Okay, so here I have my previous left and previous right, and after that what I will do, I think, yeah, added star everywhere, right? Tree node star, tree node star, yeah, I think I have added star everywhere. So now what I should do after that, okay, after that I have stored my previous left and previous right, right? So what I should do, after this node I will make a new left. This node dot left will become equal to new tree node that will contain the value 12. Okay, same for the right, node right will be equals to new tree node that will contain the value, where is it, yeah, that will contain the value well. Okay, so this is it, and after that I have added a new row, right? I have added a new row, but after adding this I should also restore my previous tree, right? So what I will do, I will do that previous left, that means node dot left and left of that, right? Node dot left will become equals to previous left, right? And the previous node dot right will become equal to previous right. Okay, so this is what we should do, and I think we are done with everything. So let us try to give it a run. But before that, as there are no test cases right now, so we should give a manual test case. Okay, so what test case we will give, simply let me write a tree. So I'll pass a level order of that tree. Okay, and then we will try to make the tree that we got as the answer. Okay, so I'll make a tree that is 1 2 3, it is 3, here 4, then null, and then 5, right? And then okay, this is it. So we'll make it till here only. Okay, so this is what we will send as the input. So let me send this as the input. Okay, and in which level we should add something? I will say at level 2 let us add 9. Okay, that means 1, this is level 2, right? So we'll add 9 here, 9 here, and previous tree will be restored. That means 2 here, 4 here, and null, 3 in the right of it, and 5 in the left of it. Okay, so this is what we will get as the answer. So let us give it an input of this type. So I'll give an input in the level order way, right? So first is 1, then 2, then 3, then 4, and then null, and 4 null, 5 null. Okay, so this is what I have as the input, and where I should add something, the value which I'll add. First of all, I have input as the value, right? This is value as the input, and then depth. So I'll add a value that is 9, right? I'll add 9, and depth is 2. So let us try to give it a run, and let's check if our answer is correct or not. So we are getting a tree. So let us try to construct this tree. Okay, so I'll take the help of a black pen, and I'll make this tree 1, and then 9 in the left of it, and in the left we have 2, and in the left we have 4, and in the left we have null. Then we'll go to right is also null, then this one right is also null, then here 9, we have 9, and 9 has also null, then 1 has 9. Okay, we are here at 9, and then it has left null, right 3. Okay, then it has left 5, and right it has left 5, and then left has 5, left has null, right? 5 left has null, right has null. So 5 null, and then it has right null. So this is what we are getting. Is this the same tree? I think it is the same tree which we are supposed to get, right? 1, then 9, 9, then 2, 3, then 4, 5, right? This is the same tree. So I hope that this example is clear. So let us try to give one more example. So the tree will be same. So I'll take tree 1, 2, 3, again 4, then null, and then in the left we'll have 5, right? So 5. Okay, so again it will be same, but this time we'll add something into the something else level. That is we will add 9 to the level 1. Let us say it was level 1. Okay, so to the level 1 means it is the edge case, right? So we are supposed to get new root, that is 9. So we are getting a new root. So let us try to make a tree with the help of this output. So here we have 9 as the root, then 1 in the left of it, then 2 in the left of it, then 4 in the left of it, and then null in the left of it, and then we'll go to right, null, then again right, null. Okay, and then after that we have 3, and after 3 we have left 5, and then null in the left of it, null in the right of it, null in the right of it, and null in the right of 9 also. Okay, so this is what we are getting. I think it is only the answer that we are supposed to get, right? Because here we are supposed to make a new root and add this previous root to the next of it. Okay, so I hope that you got this question completely. Okay, and you can try to make these tree by yourself also. Okay, as the output will also be available when you will do this. But still, if you will make these kind of trees, then it will be helpful in doing dry run, right? It will be helpful in doing dry run. So that is why I'm asking you that try to make these kind of trees when you get the result. Okay, when you get the answer, so try to do dry run by making these kind of trees. So I hope that you got this question completely, and also the test cases will be available when you will try it. Okay, right now these are not available in our website, but when you will do it, these will be available. So that's all for this video. We'll meet in the next video now. So till then, goodbye, take care, and also don't forget to like this video. Also subscribe our YouTube channel. You can also share this video with your friends. So goodbye, take care, bye.